In the previous video, video 1 of lesson 8, we built a decision tree for this cost minimization problem. We saved it as lesson underscore unit 8 underscore your last name, snar's mine, and then we created it in a worksheet named L1. What we're going to do now is we're going to do the second part of this lesson. In the second part of the lesson, the first thing you want to do is you want to format your spreadsheet. So it looks like this. There's this part that goes from cells A1 down to cells D18. And then there's this part that continues from A21 down to cell 29. I've already formatted that in L2 of my Excel file. So let's go back to the top here. Pharmaco must decide whether to make a new drug. The new drug is currently part way through the development process, and some fixed development costs have already been incurred. Pharmaco classifies the possible market results as great, fair, and awful, and it estimates the probabilities of these outcomes to be 0.458, 0.355, and, well, we can calculate that right here. We got great, fair, awful. This is 0.458. This is 0.355. And then this probability is equal to 1 minus that minus that. 0.187. All three of them should add up to 1, which is the case. The company estimates that the corresponding sales volume in units sold from these three outcomes are 600,000, 300,000, and 90,000. So this is 600,000, this is 300,000, and this is 90,000. If the company proceeds with the new drug, it incurs an additional fixed cost of product development, $6 million, and will receive the selling price less variable cost at $17.87. So my unit margin is 17.87, and the fixed development cost is 6 million. If the economy is great and sales units is 600,000 and the unit margin is $17.87 per unit, I should change this to per unit. Then the gross margin under a great economy or great market would be this unit margin times unit sales. Now, before I hit enter, I'm going to drag this down to calculate the gross margins for fair and awful. In order to do that, I need to freeze this blue box in row 5. I'm going to put a $sign between the B and the 5. Then I can drag this down. Now, I want to calculate the expected gross margin. I can type equal some product of the probabilities and the gross margins. And that's what this is telling me right there to do. Expected income is the difference between expected gross margin and this fixed development cost. Let's plug the values in and see if we got them correct. Welcome back. I just verified that we are doing the work correctly. We're going to create a decision tree there. And then we're going to change this to an event with 3 branches, 1 for each state of the economy. We don't need to do it here because decision 2 is to abandon the project altogether. Up here, we're going to change event 1. I'm going to type equals and click on great, enter. I'm going to click on event 2, click on fair, click enter. Event 3, I'm going to type over it equals and awful. Now these probabilities are all 0.333 because there's 3 events and the default is assume that they're equally likely. So I'm going to type equals here and then click on that probability, enter. I'm going to click equals here and then click on this probability enter. I'm going to type on equals, type in equals, and then click on that probability and hit enter. Decision 1 is to proceed in market. I'll change this to D1. And I'll change this to D2. Decision 2 is D2, abandon. If we proceed in market, we have to incur that cost. Now, this is a cost, so we're going to make it negative. I'm going to put a negative sign between the equal sign and the B4. The gross margin that is associated with a great market and a probability of 0.458, that is this value. Then I got a probability of 0.3555. That's fair. That outcome corresponds to this gross margin. And this probability and that outcome corresponds to that outcome. Okay, the way this spreadsheet is built, this value takes development cost subtracted from the gross margin. This number is the gross margin less the development cost. This number is the gross margin less the development cost. This is the sum product of this probability and that value plus this times that plus this times that. And then here we're taking the maximum of this expected net income, which is that value there, and 0. If we abandon, no benefits, no cost. So our best decision is to proceed in market because the expected net income is positive. The expected gross margin is 0 and the expected net income is 0 for decision 2, abandon, right? There's nothing spent. There's nothing received. Let's type that in here, 0 and 0. According to the decision tree, the expected monetary value equals the better of these two outcomes. So in my case, that value. I don't want any commas or dollar signs. Since it is positive, the company's best decision is to proceed and market the new drug. Now we're going to perform a sensitivity analysis to see how a percentage decrease in all sales volume affects the expected monetary value and the firm's decision. Format cells A2, which I've already done, to C29 to look like the table below. Type 0% in cell B23. So 0, we're going to start with 0% here. Type equal 1 minus B23 times B13 minus B4. So I'm just going to copy this into B25. I'm not including quotation marks. This B13 is that value. And we're multiplying it by 1 minus this decrease in sales. It's currently 0%. So that part reduces the red box by whatever percent's in here. So it's reducing it by 0%. And then it's subtracting off the fixed cost of development. Now we want to highlight cells A25 to B29 to create a data table. So I'm going to go to data, what if analysis, data table. And these percentages are in a column and they're percent reductions. So I'm going to click on that and then click on the 0% and click OK. So let's put in our 0% here. That's our starting value. And then our expected monetary value for a 0% decline Our expected net income, if we have a 5% decrease in sales, is $758,854. For a 10% decrease, it's $403,125. For 15% decrease, it's $47,396. And for a 20% decrease in sales, it's $8,334. It's a loss, so we have to make it negative. We could automate the decision here with an if statement, equal if this is positive, then quote unquote D1. Otherwise, D2. I could drag that down. The only one that is decision 2, abandon, is where the expected net income is a negative $308,334. So this is D1, decision 1. This is D1. This is D1. And this is D2. If sales volume decreases by 5%, the company should what? Proceed and market. If the sales volume decreases by 10%, the company should proceed and market. If the sale volume decreases by 15%, the company should proceed and market. If the sales volume decreases by 20%, the company should abandon the new drug.